Hello guys, welcome on Tesla Adventures. In this video today, we are going to discuss the formation of P-N Junction diode and the junction theory. So you can see that we as its name suggests that P-N Junction diode is formed by deliberately joining P-type crystal to N-type crystal with a semi-permeable membrane in between. Now let me tell you that how it is done. So one P-type crystal is taken with some doping concentration and other N-type crystal is taken with same doping concentration. Okay, so the doping concentration of both the crystals should be same, and there is a semi-permeable membrane which allows only the passage of electrons and holes through it, and it does not allow the passage of ions through it because ions have a comparatively greater size. So this is a semi-permeable membrane which is kept in between this p-type and n-type semiconductor, and they are heated to a higher temperature and they are joined with the semi-permeable membrane in between. Now this complete diode is allowed to cool down for some time, and in the cooling down process a current flows inside the diode. And let me tell you that what is that current. So we know that there is a process called as diffusion. You have heard about the diffusion in chemistry also, and let me tell you a very simple example of diffusion. That you know that in LPG cylinders the gas is filled at a higher pressure and compressed state, and when we press the knob of that cylinder, then gas diffuses out of the cylinder at a very faster rate. So diffusion is a process in which anything which has a higher concentration automatically moves from higher concentration to lower concentration due to the difference of concentration. So this is a process of diffusion, and you know that in P side or in P type of crystal, the concentration of holes is in excess, and in N type of crystal, electrons are the majority charge carriers, so the concentration of electrons is large in N side. So what happens that these holes diffuse from higher concentration to lower concentration, which means that from P side to N side, and these electrons diffuse from higher concentration to lower concentration, that is from N side to P side. So there is a current which flows in the diode from the junction, and this current is the diffusion current, and you know that holes behaves like positive charges. So if they are diffusing from P to N side, then their current would also be flowing in the P to N side direction. And electrons are diffusing from N to P side, and obviously as they are negative charge, so their current would be in the opposite direction from P to N type. So the direction of hole current and electron current is same, and it is from P side to N side, and the total current, which is called as diffusion current, is the sum of these two currents flowing through the junction of the diode. Now as a result of which, what happens that these holes when they are flowing, when they are diffusing towards N type crystal, and these electrons when they are diffusing towards P type, they recombine with each other at the junction, and due to this recombination, heat energy is released. In fact, energy is released in form of photons. You know that if we have to jump an electron from valence band to conduction band, we have to give some energy to that electron. And now what is happening, that electron, which is a free electron, which is already in the conduction band, is going back to the covalent to the valence band, and it is recombining with the hole. So this is a reverse process, and hence in this process the energy would be released in form of photons. And when these photons are in the visible range, then we say this diode is a light emitting diode, LED, which we would be discussing in detail in the upcoming videos. So due to this recombination, photons are emitted from this region, junction. But there is a effect which happens that this semi-permeable membrane does not allows the acceptor and donor ions to pass through it, and hence acceptor and donor ions are accumulated near the junction like that. And due to their accumulation, there is an electric field which is produced from N side to P side, because positive charge, which is positive ion, which is donor ion, is towards N side of the crystal, and negative ion, which is acceptor ion, is towards P side of the crystal. So an electric field is formed which is pointing from N side to P side in the region which is nearby the junction. And in this region, as electrons and holes are recombined completely, so there is no electron and hole, and this region is depleted with electron and hole. Now depleted means that this region has a deficiency of electrons and holes. So this word depletion means deficiency. So therefore we call this region as depletion region. Okay, so this region is formed and a barrier electric field is formed in this region, and a barrier voltage is formed in this region. And if I would represent this voltage by a battery, then I would connect the positive terminal of this battery towards N side and the negative terminal of the battery towards P side. So this is a barrier potential, and barrier potential is 0.3 volt for germanium and 0.7 volt for silicon. You have to remember this, that barrier potential for germanium is 0.3 volt and for silicon it is 0.7 volt. Now why these are called as barrier? Because you can see that diffusion current is flowing like that, and this field, this region and this potential is developed due to the diffusion of majority charge carriers. But now what will happen, that this holes, which are the positive charges, will experience a force which is acting in this direction like that, and these electrons, which are the negative charges, will experience a force in this direction like that. So this barrier field is pulling the holes away from the junction and pulling the electrons away from the junction. So this barrier field is decreasing the diffusion current. It is opposing the diffusion current. So diffusion current eventually decreases. Now there are some minority carriers also in P side, and in P side the minority carriers will be electrons, and in N side the minority carriers will be holes. So this electric field, barrier electric field, is pulling these electrons towards the junction, minority carriers, and is pulling these holes towards the junction, majority carriers. Okay, so due to this pull, these electrons, which are the minority carriers at P side, are moving towards the junction, and holes are moving towards the junction. So there is a current which is flowing from N to P side, which is supported by this barrier field, and this current is called as drift current. Now this drift current is named drift because this is due to the minority charge carriers. So it is very small. But as barrier field is supporting this current and barrier field is opposing the diffusion current, so at a very less value of diffusion current, the value of diffusion current and drift current becomes equal, and net current through the diode junction becomes zero, and diode is said to be in saturated state. So when you are holding a diode without any battery connected to it, it would not give you a current spikes, because obviously no current is flowing through that diode as it is in the saturation state. And this saturation state is completely achieved till the cooling down. When we have connected these two at high temperature and it is getting cooling down, it is getting cooled down. In this cooling down process, this complete diffusion process occurs, and the net current through the junction of the diode at the end of the cooling down becomes zero, and diode attains the saturation state. Now in the next page I have already written this theory for your reference. You can take the screenshot to make the notes, and these are those points which I have already discussed in the same video. and this is also the theory points which you can refer for your notes making. You can take the screenshot, and this is the fact that which I have told earlier, that in the saturation state net current flowing through the junction of the diode becomes zero. Now it is very important to discuss another two effects, that what is the effect of temperature on the width of depletion region, and what is the effect of doping concentration on the width of depletion region. Now, as we have already discussed, that depletion region is called as depletion region due to the fact that it is depleted with the charge carriers, which means that there are no electron or holes present in this region, and therefore this region is called as depletion region. But let us imagine a situation in which we are increasing the number of electrons and holes. We are generating the number of electrons and holes by increasing the temperature, because you know that on increasing the temperature thermal agitation occurs, and due to thermal agiation number of electron holes are increased in the crystal. So if the number of electrons and holes are increasing continuously in the crystal due to increase in temperature, the region in which the electrons and holes are not found will shrink, and there will be a very tiny region in which electron and holes will be depleted. So we can say that depletion region width will decrease on increasing the temperature. And the same thing occurs with the doping concentration. When we will increase the doping concentration of P side or N side, then we are actually increasing the number of holes at P side and number of electrons at N side. So if we are filling the holes more and more in P side, and we are filling the electrons more and more in N side, then this region in which the electrons and holes are depleted will decrease, and there will be a very tiny shrinked region near the junction where electrons and holes will not be found. So this depletion region width will also decrease on increasing the doping concentration. So this was the complete junction theory and the formation of P-N junction diode. And in the next video we will be discussing the biasing of diode, which means that we would be connecting the battery to the P-N junction diode. Thank you.